Good to have you back. So in this lesson, I'm going to walk you through finding the equation of conic sections in a standard form given its general form. And then based on that, we're going to find all the necessary information that you can extrapolate from the standard form. And then finally, graph the conics. Okay, so two questions I got. I'm not going to do the example of a quadratic because the quadratic functions I've gone through it a few lessons, so you already should know how to do that. Okay, so first question is given by this general form. We want to find out what kind of a conic it is and then go through it and extrapolate all the information we want to get. Now, the first thing is that by just looking at this, just a very quick observation, you should be able to say right away what kind of a conic this is. So the idea is that if you see the x squared and a y squared term, and if they're separated by a negative, so this is x squared minus y squared, yes, there is 2 in front and a 3 in front, but this negative sign in between them, between the square terms of x and y, that actually gives you the sign, the very important signature of hyperbola, okay? And if this was plus sign, that means that both of them, both of the x squared and y squared terms, they are positive. That means you're going to have an ellipse. All right, now knowing that it is in hyperbola, that's okay. That's just, we identify that, but that's not going to help us with anything else. We just have to go through and then figure out what the standard form is and then extrapolate all the information. Okay, let's go ahead and do that. And we're going to use, you guessed it, we're going to use completing the square method. Okay, this is from grade 10 and 11 or algebra 1 and pre-algebra. So that's what we're going to do. We're going to first rewrite this in a easier, nicer form, and then we're going to do the completing the square. So let's collect the x's and the y's in one side and then go from there. So let's separate x's and the y's, and then we're going to remove the 11. We're going to put it on the other side of the equation. So now we collected the x's and y's. So now we have these two, and I separated them purposely so that you can see what is happening. There's still one term and there's nothing wrong with this. I just want to make sure that you understand that you have to add something in here and something in there to make both of these perfect square trinomials, and then we go from there. But it's not as easy because you've got these coefficients of 2 and 3. It's actually 2 and negative 3, so we have to deal with that, so it makes it a little bit more interesting. So let's go ahead with the first thing we got to do. We got to factor those out. So let's do that. First, from the x, we're going to close the bracket, and then the next one, we're going to factor negative 3 out, and we get y squared plus 2y, and then close the bracket, equals to negative 11. We have not done anything else. We just did the factoring. Remember the completing the square method, and that's what we're doing. All right, so now we're going to go through. We're going to add. So what do we have? We have negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4. And then on this side, we have 2 divided by right here. So this was the negative 4 we dealt with. Now we're going to deal with the negative positive 2. So positive 2 divided by 2 is 1. 1 squared is 1. I'm going to add 1. And now here's the trick. We added 2 times 4. So we just added 8 on this side, the first part of the trinomial. And then on the second part, we subtracted negative 3. So together, we added positive 5. Therefore, we have to add positive 5 to the other side. Okay, that's what we need to do. Okay, so now that we have this, what are we going to do? We need to now rewrite this and put it into the binomial squared. So we get 2 times x minus 2 all squared, and it is minus because of that negative. And then we're going to rewrite the other one, negative 3, open the bracket, that's y plus 1 all squared. And that's equal to, so we'll have 2 times x minus 2 all squared minus 3 times y plus 1 all squared. And that's equal to -6. Okay, very good. All right, now that we have this, we have to make it into a standard form. That means first we have to divide everything by -6. So that's what we got to do. We got to divide everything by -6, every single term. Remember, the standard form of an ellipse or a hyperbola, they are equal to 1. Okay, so that's what they are. So here what we have is -x minus 2 all squared over 3. So I put the negative in front of the bracket instead of putting a -3 in the bottom. The next one would be positive y plus 1 all squared over 2. That's equal to 1. All right, now we're going to rewrite this, and you will get y plus 1 all squared equal to 2 minus x minus 2 all squared over 3. What we did, we just swap the y term and the x term over so that it looks nicer. And this way you can actually read off of whatever information that you need to. So in this case, let's go ahead and write up what is it that we do have. Center is, now center in here, x first, right? So that would be 2 and -1 because of y plus 1 and x minus 2. That's the center of the hyperbola. We know that it's a hyperbola because of this negative right here. All right, so that's the hyperbola right there. Then the next thing that we need to do is look at the length of the transverse and conjugate axes. So here we go. First of all, what is the transverse? We have a vertical transverse axis. The length of that is a square root of 2, because you have to square root of the base, the denominator of what you get terms, and then multiplied by 2. So 2 root 2 is the length of the transverse axis. Okay, and it's vertical. The next thing is horizontal conjugate axes. And why is the horizontal? Because of that negative. Okay, and the length of that is 2 times root 3. That's the length of that. Okay, very good. All right, when you graph the information, center is given to you, which is right here, and that's the center 2, -1. Then based on that, you have to use the transverse axis and conjugate axes and create this box. And then the two asymptotes crosses the center of the hyperbola, right? And corner to corner of that rectangular box. And once you have that, you can actually come up with the equation of asymptotes, which is given by this, if you remember that when we talked about hyperbola, and then just plug numbers in and then get the equation of it. But remember, h and k were the center. So in this case, when you have finished that, you get one part of the graph at the bottom right here, which is, I've drawn it with pink, and then the top part is going to be something like this, and the top part will be like this, and you are done. Now, let's write up the equation of asymptotes, and we're done. And here it is. This is the two equations for the asymptotes right there. Okay, all right, next question. So this is the next question. And then with the observation right away, you know that this will end up being an ellipse. We're going to go ahead and then do the completeness square method again. First, we're going to collect all the x's and the y's in one side, and then we're going to split them a little bit, leave the 61 to the other side, complete the square. So let's do that. So that is the first step. Once we have that, we have to make each of these two binomials into a trinomial that are perfect square trinomials by adding or subtracting some numbers. So first we have to remove all the coefficients, factor the first 9 out of the two terms. You get -6x, close the bracket, and then plus, factor 4 out, you get y squared plus 4y, and then equal to 61. And then we go ahead and complete the square. Half of -6 is -3. -3 is squared. You plug it back in there, and that will be +9. Okay, and here half of 4 is 2, 2 squared is positive 4, and then what we are adding 81 and 16, and together we are adding, and you add these two guys together, and you're adding 97. So that's plus 97. So let's polish that and do the math. 36, and the other side would change it to all binomial squared. And once you get that, divide everything by 36. And you will end up getting x minus 3 all squared over 4 plus y plus 2 all squared over 9 equal to 1. And that is the equation of ellipse with the center at 3 and negative 2. And we have the major axes and the minor axis we have. So the minor axis, the length of that is 4. So the square root of 4 times 2, that's the length of the minor axis. Okay, so that's 4 again. And the length of the, and by the way, that's a horizontal minor axis. And then the vertical major axis, 2 times the square root of 9, which is equal to 6. And now we can go ahead and graph it. And then when you sketch the graph based on the information that you have, you will end up getting something like this. And this is very good because you can see that the distance, the conjugate axes, and all of that information that you need to is right there. So this length right here, that is 4. We know that this length right there, that is 6. So 3 up from here to here is 3 units. So as the bottom is 3 units, and center at 3, negative 2. So, and that is the graph of that ellipse. All right, so these are the two examples of conics, changing the general form to standard form and then extrapolating all the information that we need and then graphing them. Until next time, keep well, keep at it, and check out my next video related to conics and review of the conic sections.